Hi everyone, myself Bashiria Obalarabi from National Forensic Science University. I'm a research scholar under the guidance of Prasanjit Maiti. So our topic is the photocatalytic degradation of methylene blue and methyl orange under natural sunlight using HPN Ag200 nanocomposite. So this work demonstrates the facile synthesis of a nanocomposite made from hexagonal boron nitride and silver tungsten nanoparticles. So this procedure involve depositing of Ag200 on the surface of HBN nanosheet. It was then assessed how this will affect the degradation of methyl blue or methyl orange in the presence of natural sunlight. And here, in terms of efficiency, the two compounds, either HBN or Ag200 are almost not active, while this mixture of HBN and Ag200 show better activity. So more importantly, these results are the result of ADS, FTIR, UVDRS, XRD, and PL all reveal the presence of HBN and Ag200 nanocomposites in the compound. Then the FECM results show a homogeneous dispersion of silver as well as tungsten on the surface of HBN sheet. So, in introduction, recently more and more effort have been focused on studying layered materials such as graphene. So, many previous reports proposed that a single phase semiconductor coupling with boron nitride show enhanced photocatalytic activity under visible light irradiation due to the quantum confinement and surface effect. According to some authors, BNI is the most promising and popular inorganic non-material. So in this project, Ag200 was coupled with boron nitrate sheet to photodegrade methylene blue or methyl orange in natural sunlight. And we can see from the figure below that's the photodegradation or efficiency of either Ag200 nanoparticles or BN sheets alone is very low. However, compared to BN Ag200 nanoparticles, the efficiency was reached almost 100% after 100 minutes. Also, data were collected in order to determine the behavior of of this nano composite. So here is our synthesis method. So first, a boron nitrate sheet purchased from sigma aldrich was exfoliated using sulfuric acid. Then hydrothermal synthesis of Ag200 nanocomposite particles using sodium, tungsten, and silver nitrate. Then the synthesis of the nanocomposite made into in ratio 2.1 was made using BN and Ag200 nanoparticles along with NOH as bending material. So for the photocatalytic activity measurements, under sunlight, the experiment was carried out in October between 1 p.m. and 3 p.m. Then the dye solution 5 ppm and 100 ml was mixed with 200 mg of the synthesized nanoparticles in around while. Then the mixture was stirred in dark for 20 minutes, then followed by continued stirring under sunlight for 100 minutes. And then after every 20 minutes interval, 0.5 ml of sample was collected, mixed with 0.5 ml of double dishwater. Then the UV visible absorbance was taken. So before irradiation, the suspension was first mag- magnetically stirred for 20 minutes in dark, and then at interval time 0.5 ml of this solution was taken and mixed with 0.5 double distilled water and then take the absorbance. So here is the degradation efficiency. the formula which we use to determine the efficiency of the different nanoparticles made. So here are a few characterizations we have made. The the crystal structure and morphology. So the first image is the FTCM. Then the second one is the chemical mapping of a BN-AG2004, and here we can see that the silver, oxygen, tungsten, and nitrogen was detected by our ADX machine. So the boron nitride is not detected due to like our machine is not able to detect boron nitride. So here is the corresponding ADS analysis, followed by the Raman and then the XRT of the different nanocomposites. So after that, we have the optical property of the as sensitized nanoparticles. So the first graph is the absorb the UV visible DRIS spectra. Then B the corresponding a band gap. So here we can see that our boron nitride has like 3.8 electrovolts, while AG2004 has 2.8, and then the mixture of these two has a band gap of 1. And then in figure C, we have the FTIR spectra. Then D, we have the PL spectra. And then E, in figure E, we have the lifetime, the TC spectra of the nanocomposite. So after that, we have the photocatalytic experiments of a in figure cut of methyl blue. So here we can see that the efficiency of the efficiency. So here we can see that the efficiency of AG2004 is 40.28 for BN12, and then the mixture of these two is 86.24%. So after that, in figure 5, we have the photodegradation of methylene blue, and here we can see the efficiency for AG2004 is 32, while for DN is 14, and then the mixture of these two is 1994.47%. So in conclusion, we can say that the BN-AG2004 nanocomposites were easily sensitized. Here, the two materials were bonded together and made a new hybrid nanomaterials with which diverse and unique properties such as excellent UV visible light absorbance and accurate crystalline structure. Under sunlight, the as sensitizer material exhibit a remarkable photocatalytic ability to degrade organic dye. The faster degradation of this dye under sunlight indicate that BNAG2004 nanocomposite is a promising photocatalyst. So these materials can be explored in deep for possible application. So for acknowledgement, we thank the National Forensic Science University for the material and the financial support. And here is some of the references we used. Thank you for your attention.